Imagine a vast and serene landscape, one that has stood the test of time, suddenly transformed. The Blue Mountains of Oregon, a region known for its tranquil beauty and rugged charm, recently became the epicenter of an astonishing event. An unprecedented geological upheaval has left experts and locals alike in awe, as a staggering uplift of 6,900 feet occurred almost overnight. What could possibly cause such a dramatic shift in the Earth's crust? In today's exploration, we dive deep into this remarkable incident, unraveling the possible causes, consequences, and mysteries surrounding this natural marvel. Buckle up, because this story is anything but ordinary. A seismic awakening. The sudden uplift of the Blue Mountains began with a series of minor tremors that many dismissed as routine. These tremors, however, were merely the prelude to something far more extraordinary. Unlike typical earthquakes, this event did not result in widespread destruction. Instead, the ground began to rise steadily over a span of days, leaving behind a transformed topography. This gradual but dramatic shift raised entire plateaus, creating steep cliffs and altering river courses. The phenomenon perplexed observers, as there were no immediate signs of volcanic activity, a common suspect in such cases. In the absence of lava flows or ash plumes, scientists began investigating alternative explanations. Could this be the result of deep-seated tectonic movements? Some speculate that a previously dormant fault line may have reawakened, pushing the land upward with immense force. The region's proximity to the edge of a tectonic plate suggests that long-term stress may have finally reached a tipping point, resulting in a vertical thrust. Adding to the mystery, satellite data revealed subtle horizontal shifts in the surrounding areas, indicating a complex interaction between various geological forces. The unique geology of the Blue Mountain, composed of ancient volcanic rock and sedimentary layers, may have amplified this effect. These layers, some dating back hundreds of millions of years, have been subjected to relentless pressure from plate movement. The interplay of these material, rigid volcanic rock overlying softer sedimentary strata, might have contributed to the area's remarkable uplift. Additionally, researchers are considering the role of subsurface fluids such as water or magma, which could have acted as lubricants or drivers in this tectonic event. The area's complex geological history is now under intense scrutiny as researchers piece together how such an event could occur so rapidly. Teams of geologists and seismologists have converged on the region, drilling core samples and deploying advanced imaging technologies. The findings could provide invaluable insights into the dynamic processes that shape our planet, and perhaps offer early warning systems for similar events in other regions. Meanwhile, locals and tourists alike marvel at the transformed landscape, a reminder of Earth's raw, unpredictable power. Comparing similar events. To understand the Blue Mountains uplift, we can look at similar incidents in history. One notable comparison is the 1959 Hebgen Lake earthquake in Montana, which caused a 20-foot uplift in some areas. That event, triggered by a powerful earthquake, drastically altered the local terrain and created Quake Lake. However, the scale of the Blue Mountains event dwarfs such occurrences, raising questions about whether this could be a one-of-a-kind phenomenon. Unlike Hebgen Lake, which was a violent and destructive event, the Blue Mountains uplift was a gradual and steady process, making it even more mysterious. Its speed and magnitude are unprecedented in recorded geological history, offering a unique opportunity for scientific exploration. Across the globe, places like the Andes and the Himalayas experience uplift due to tectonic plate interaction, but these changes typically unfold over millennia, not days. The Andes, for instance, are a result of the ongoing collision between the South American plate and the Nazca plate, a process that has shaped the mountain range over tens of millions of years. Similarly, the Himalayas continue to rise slowly as the Indian plate pushes against the Eurasian plate. These examples highlight the gradual nature of tectonic uplift, which contrasts sharply with the rapid transformation of the Blue Mountain. What sets the Blue Mountains apart is the speed and scale of the event. While uplift in mountainous regions like the Rockies is often measured in millimeters per year, the sudden elevation gain in Oregon has rewritten expectations. Such an anomaly raises compelling questions. Could this be a new kind of tectonic behavior? Or is it the result of a rare convergence of factors creating a perfect geological storm? Some scientists hypothesize that the Blue Mountains uplift might involve a combination of rapid mantle dynamics, fault line reactivation, and unique crustal properties. Others suggest the possibility of a previously unrecognized phenomenon, such as abrupt magmatic intrusion or the release of deeply stored tectonic stress. The event's speed could also imply the involvement of subsurface fluid dynamics, with pressurized water or magma facilitating sudden movement. Geologists are comparing this event to rapid uplift zones, such as those in Iceland, where volcanic activity plays a key role in shaping the landscape. Still, the absence of typical volcanic markers in the Blue Mountains case, such as eruptions or lava flows, adds a layer of complexity. As data from this event is analyzed, it could reshape our understanding of Earth's tectonic systems and the potential for rapid geological changes in other regions. Theories behind the event. Several theories attempt to explain this uplift, each offering fascinating insights into the inner workings of our planet. One possibility involves magma intrusion deep beneath the crust. Although no volcanic eruptions were observed, it is conceivable that molten rock forced its way upward, displacing the land above it. This theory aligns with the region's volcanic history, given that the Blue Mountains sit on ancient volcanic foundation. However, the absence of heat signatures, seismic activity indicative of magma movement, or gas emissions typically associated with such events complicates this explanation. If magma were indeed the culprit, it may represent an unusually quiet or deep-seated intrusion, unlike anything previously documented. Another hypothesis suggests a phenomenon known as isostatic rebound. This occurs when the weight of overlying ice sheets or heavy sediments is removed, allowing the crust to rise and restore equilibrium. This process is commonly seen in areas like Scandinavia or Canada, which were once buried under massive glaciers. While the Blue Mountains lack a glacial history, there is speculation that ancient tectonic stresses or erosion of overlying materials might have triggered a similar effect. For instance, erosion of sedimentary layers over millions of years could have gradually lightened the load on the crust, setting the stage for this sudden uplift. Alternatively, subterranean water movement might have played a role. Vast reservoirs of water trapped deep underground can create immense pressure, potentially forcing the land above to rise. This could occur through mechanisms such as aquifer pressurization or the movement of superheated fluids along fault lines. However, confirming this theory would require detailed hydrological studies, including mapping the region's underground water system and analyzing pressure changes during the uplift. The challenge lies in pinpointing which of these mechanisms, if any, is responsible, or whether an entirely new geological process is at work. The complexity of the event suggests that multiple factors could have converged, creating a unique combination of forces. For instance, magma intrusion could have coincided with fluid pressurization, or isostatic rebound might have been amplified by localized tectonic stress. Geologists are now deploying advanced tools to investigate the area, including satellite-based ground deformation monitoring, seismic imaging, and chemical analysis of soil and groundwater. These efforts aim to identify the specific drivers behind this dramatic event. Whatever the ultimate cause, the Blue Mountains uplift underscores the dynamic and interconnected nature of Earth's systems, reminding us that even seemingly stable landscapes can change with breathtaking speed. Environmental consequences. The dramatic shift in elevation has already begun to reshape the ecosystem, creating a cascade of changes that affect both the natural environment and the species that inhabit it. Rivers that once meandered through the valleys have altered their courses, carving new paths through the uplifted terrain. This redirection has disrupted aquatic ecosystems, with fish and other water-dependent species forced to adapt to unfamiliar conditions or migrate to more stable habitats. Floodplains that previously supported a rich diversity of life may now dry out, while new wetlands could form in unexpected areas. Wildlife habitats have also been significantly affected. Animals that relied on the lowland environment are now contending with steeper landscapes and different vegetation, pushing some to relocate to more suitable areas. Predators and prey may find themselves in new proximity, potentially altering local food webs. Conversely, species accustomed to higher altitudes might find new opportunities as the uplifted terrain creates conditions similar to their original habitats. For instance, certain alpine plants and cold-adapted animals could expand their ranges into the newly elevated area. Interestingly, the uplift may create unprecedented opportunities for scientific discovery. The exposed rock layers, some of which may not have been visible for millions of years, could offer invaluable insights into Earth's distant past. Paleontologists may uncover fossils that reveal information about ancient ecosystems, while geologists could identify minerals or formations that shed light on the planet's tectonic history. Additionally, the uplifted terrain might provide clues about prehistoric climates, potentially offering evidence of long-extinct weather patterns or ancient environmental conditions. However, this newfound accessibility comes with significant risks. The stability of the uplifted region remains uncertain, as the rapid rise may have weakened the structural integrity of the land. Landslides, rockfall, and erosion pose ongoing threats, particularly in areas where steep cliffs have formed. Sudden changes in the landscape could also destabilize human settlements or infrastructure nearby. Balancing exploration with conservation will be crucial in the coming years. While the scientific potential is immense, excessive human activity could exacerbate erosion or further disrupt fragile ecosystems. Environmental scientists, geologists, and conservationists will need to collaborate to develop strategies that allow for both careful study and the protection of this transformed landscape. In the meantime, the uplifted Blue Mountains serve as a striking reminder of nature's power to reshape the world and the profound challenges and opportunities such events bring. Human impact and local reactions. For residents of the Blue Mountains region, the uplift has been both a spectacle and a significant challenge. Farmers and ranchers, whose livelihoods depend on the land, have been among the most affected. Fertile fields, once ideal for crops or grazing, are now fractured or elevated beyond usability, making traditional farming methods nearly impossible in some areas. Irrigation systems have been disrupted as water sources shift or dry up, leaving many to grapple with how to adapt to the transformed terrain. Livestock have also been impacted as fences are destroyed and grazing areas become inaccessible. Infrastructure damage has added another layer of difficulty. Roads and bridges, vital for connecting rural areas to towns and cities, have been cracked, warped, or entirely destroyed. Some communities have found themselves temporarily isolated, with emergency services struggling to navigate the damaged landscape. Local economies, heavily reliant on agriculture and transport, face slowdowns as businesses work to adjust to the new reality. Yet, amidst these challenges, a sense of wonder and opportunity has emerged. Stories of the uplift have drawn visitors eager to witness the phenomenon firsthand, creating a surge in tourism. Hotels, restaurants, and local guides have reported increased activity, providing a much-needed economic boost to some towns. For others, the event has inspired a sense of pride in the region's resilience and natural beauty. Communities have begun organizing events and tours to showcase the transformed landscape, emphasizing their adaptability and resourcefulness in the face of upheaval. For many residents, the uplift has become a symbol of the unpredictable but awe-inspiring forces of nature. Local schools have incorporated the event into their curricula, teaching students about geology, ecosystems, and the importance of resilience. Artists, photographers, and writers have also found inspiration in the changing scenery, capturing the drama and majesty of the altered Blue Mountains. The blend of awe and adaptation underscores the human spirit's ability to navigate unpredictable circumstances. While the road ahead may be challenging, the region's response demonstrates how communities can find strength and opportunity in the face of adversity. As recovery and adjustment continue, the uplift is sure to leave an enduring mark, not just on the land, but also on the people who call it home. A global perspective. The Blue Mountains uplift has captured international attention, drawing geologists, scientists, and enthusiasts from around the world to study and debate its implications. Comparing this event to similar phenomena in regions like the Andes or the Himalayas highlights intriguing differences. While those iconic mountain ranges are products of slow, ongoing tectonic processes that unfold over millions of years, the rapid uplift in Oregon defies typical geological timeline. This stark contrast underscores the remarkable diversity of forces shaping our planet, challenging long-held assumptions about the speed and nature of tectonic activity. Unlike the Andes or Himalayas, where plate collisions drive gradual uplift, the Blue Mountains event suggests a more localized and abrupt mechanism. Some researchers are exploring whether unique subsurface conditions, such as pressure from deep-seated magma or fluid dynamics, could explain this anomaly. Others are comparing it to sudden uplift events in volcanic regions, like Iceland, though the absence of visible volcanic activity adds complexity to this case. These comparisons are driving international collaboration as experts seek to unravel the mystery and refine global models of tectonic behavior. The event has also reignited discussions about the interconnectedness of Earth's systems, emphasizing how changes in one area can ripple across vast distances. Could the Blue Mountains uplift influence weather patterns, hydrological systems, or seismic activity in neighboring areas? Some scientists hypothesize that the release of subterranean pressure could realign stress along fault lines, potentially triggering aftershocks or seismic events in distant locations. This possibility has prompted the deployment of monitoring equipment not only in Oregon, but also in regions hundreds of miles away to track any correlated activity. Additionally, there is growing curiosity about how the uplift might interact with atmospheric and ecological systems. The altered topography could influence local weather by redirecting wind patterns or changing precipitation zones. On a broader scale, shifts in Earth's crust can have subtle but measurable effects on the planet's gravitational field, potentially influencing ocean currents or atmospheric circulation. Understanding these potential ripple effects is vital for predicting and mitigating future risks. Scientists are using advanced techniques, including satellite imaging, ground-penetrating radar, and seismic modeling, to analyze the uplift and its wider implications. These efforts aim to create a more comprehensive picture of how localized geological events can impact global systems. As the study of the Blue Mountains uplift progresses, it serves as a reminder of Earth's dynamic and interconnected nature. The event not only offers a rare glimpse into powerful geological forces, but also underscores the importance of global scientific collaboration in understanding and preparing for the planet's unpredictable behavior. Cultural and historical reflections. The Blue Mountains have long been a place of profound cultural and spiritual significance for indigenous communities who view the land as sacred and deeply interconnected with their traditions and identity. The recent uplift has only deepened these connections, with some indigenous leaders and community members interpreting the event as a powerful symbol of renewal or transformation. For many, it serves as a reminder of the land's living spirit, reinforcing the belief that the earth itself is dynamic and imbued with meaning. Historical records and oral traditions may offer valuable insights into past geological changes in the region, enriching scientific understanding of the present event. Indigenous stories often carry knowledge of environmental shifts that occurred over centuries, passed down through generations in the form of myths, legends, and ceremonies. These narratives could provide clues about earlier instances of uplift, earthquakes, or other significant changes, offering a unique perspective that complements scientific analysis. The uplift also invites broader reflection on humanity's relationship with the natural world. Modern societies, heavily reliant on technology and infrastructure are often unprepared for the unpredictable power of Earth's forces. This event serves as a humbling reminder of the limits of human control and the need for respect and stewardship of the planet. While science can offer explanations and prediction, the uplift highlights the intrinsic unpredictability of nature, challenging assumptions of stability and permanence. As global communities grapple with challenges like climate change, deforestation, and resource depletion, the Blue Mountains uplift underscores the interconnectedness of all living systems. It serves as a call to action, encouraging a shift toward more sustainable practices and a deeper appreciation for the natural world. Indigenous communities, with their deep-rooted traditions of harmony and reciprocity with the environment, offer lessons in resilience and stewardship that are increasingly relevant in today's context. The uplift is not merely a geological phenomenon, it is a cultural and spiritual moment, sparking dialogue about the balance between progress and preservation. It reminds us that while humanity is a powerful force, it remains a small part of a much larger, dynamic system. In this sense, the event stands as both a challenge and an opportunity, a challenge to reimagine our role in shaping and protecting the Earth, and an opportunity to learn from those who have long understood the profound wisdom of living in harmony with the land. Mysteries yet to solve. Despite ongoing research, the Blue Mountains uplift remains shrouded in mystery. Key questions about its causes and implications linger, fueling speculation and debate. Could this event be a precursor to more dramatic geological changes? Or is it an isolated anomaly that will fade into history? The search for answers is as much about understanding our planet as it is about preparing for the future. Each new discovery brings us closer to unraveling the complexities of Earth's dynamic systems. As the story of the Blue Mountains unfolds, it challenges us to remain curious, vigilant, and open to the unexpected. Engage with us. Leave a comment below and let us know which discovery amazed you the most. Do you think there are more Ice Age fossils or hidden caves still waiting to be found? We'd love to hear your thoughts and theories. Don't forget to like, share, and subscribe to stay updated on more amazing discoveries and hidden wonders from around the world. Hit the bell icon so you won't miss our next adventure.